In this video, we are going to look at the range. Now, before we could talk about the range, we want to look at what is discrete and continuous variables. So first, let's look at what is discrete variables. So a variable which can have only certain values is called a discrete variable. For example, the number of children in a family can only take whole number values such as 0, 1, 2, 3. Now, I'd just like to point out that discrete variables don't necessarily have to be whole numbers. As long as you only have certain values that the variable can take, and those values can be fractions as well, but as long as there's only certain values it can take, the variable will be discrete. Example, we have shoe sizes, and shoe sizes could be like a 4, then it could have a 4.5, then it could have a 5, and a 5.5. This would be discrete variables because 4, then 4.5, 5, then 5.5, and so on. So that's not pretty common here, etc. Now, when I explain continuous variables, you'll see a difference between discrete and continuous. So before I write it down, a continuous variable is a variable that can take any value between two given points. For example, if you're measuring the heights of people, between any 2 points, let's say this is the 170 centimeter mark, and this is the 171 centimeter mark. I could have somebody as 170.1 centimeters tall. Then I could have somebody as 170.11 centimeters tall. Then I could have somebody as 170.2, 170.2598, and so on. So there's an unlimited amount of possibilities between 170 and 171. So the heights of people would be a continuous variable. And that would be the difference between a discrete variable and a continuous variable. The discrete variable can only take certain values, whereas the continuous variable could take any value between 2 points, and it's unlimited. All right, so I have a variable which can take any value between two given values is called a continuous variable. Example, height of a person can be, we have 170 centimeters, 170.223, and where we have this 170 with a long decimal here. But the fact is, based on the accuracy of your instrument that you're measuring with, this decimal could go a lot longer than this. So now, when it comes to a frequency table, depending on whether you have a discrete variable or a continuous variable, would affect how you work out the range. Now, if you have raw data, it doesn't matter. If the variable is discrete or continuous, the range is as the highest value, take away the lowest value. But there's a difference when we have a table. We need to know whether the variable is discrete or continuous, which would affect the way we work out the range. So for example, if I had some data 3, 5, 7, 1, 8, 11, 20, all right, my range would simply be the highest value, take away lowest value. So when I look here, my highest value is 20. So write 20 here, take away, and my lowest value is 1. So we have 1. I'll just shade that. All right, so we have 20 here. So 20, highest value, and the lowest value is 1, so 1 here. And of course, 20 take away 1 is simply 19. And that will be my range. Even if I were to have decimals, like example here, we have 170.32, 180.493, 172.5. My range will simply be what is the highest, take away the lowest. So the highest is this 180.493, and the lowest is this 170.32. So again, my range will be my highest, take away my lowest. So I'll have the 180.493 take away the 170.32. All right, so 180.493 take away 170.32. And that's 10.173. Now, let's go and look at frequency data. So I have a simple table here, some marks and number of students. Now we know marks, some people give half mark, but still, marks will go up in specific intervals, therefore the marks would be a discrete variable. And therefore my range would be my highest value take away my lowest value. So my highest value is 5 and my lowest value is 1. So I'll have my range would just be 5 take away 1, which will be equal to 4. Now that's pretty simple because these marks were discrete variable. All right, so here I have a table with the variable being the height. All right, and we have 170, 171, 172 like that. Now we know the height would be a continuous variable because you'll just estimate, if you get 170.5, it will fall within this category here as 171. You just approximate it. If you get 170.4, it will fall here. All right, so it's a continuous variable. Of course, approximations would have been used to make this table, and therefore the range is not going to be the highest take away lowest, 174 take away 170. What we need is the highest upper class boundary. So you go 0.5 more than the highest, which is 174.5. Take away the lowest lower class boundary. So for 170, the lower class boundary will be 0.5 less, which will be 169.5. All right, so let's include this. The lower class boundary for the 170 is 0.5 less. So that's 169.5. And the upper class boundary for the 174 will be 174.5, 0.5 more. And therefore the range now would be this highest upper class boundary take away the lowest lower class boundary. So that'll be equal to the 174.5 take away the 169.5. And that would be equal to 5. All right, 5 centimeters because we're dealing with heights here in centimeters. So the range will be 5 centimeters. And here I'm supposed to put 4 marks. All right. That'll be a range. Put the unit. So that's the difference when you're working out the range. When you have a continuous variable for frequency data, it's the highest upper class boundary value take away the lowest lower class boundary value. Again, when you have frequency data and you have a discrete variable, it's just the highest value take away the lowest value. And of course, if you just have raw data, you're just looking for what's the highest value and the lowest value and take them away. Whether you have whole numbers or decimals, it doesn't matter. Highest value take away the lowest value. And that will bring us to the end of this video.